Okay, let's talk about soft bit based network coding. As I said before, the soft bit based network coding is the very special case of the physical layer network coding. Actually, it cannot be used alone, so it must be jointly used with the channel coding or modulation methods. Okay, first let's see what is the soft bit. In the physical layer, the receiver has to convert the received symbol signals into the bits. However, in this phase, the demodulator can make two types of bits: hard bit and soft bits. Actually, the hard bit is just normal digital bits, but the soft bit is not the digital bit actually. Okay, let's see some examples. There are QPSK constellations. When a certain receiver receives the red symbol signal, how can we decide what did the sender transmit among the four white QPSK symbols? Can you guess? Yes, you are right. If there was no critical errors during the transmissions, maybe the sender transmitted the 00. Yeah, actually this is a very simple decision method. Yeah, they just use the distance. Since the received symbol signal is very close to the symbol of the 00, the demodulator will just do the hard decision. Okay, let's see another example. If the received symbol is here, what is the transmitted symbol? It seems to be close to the symbol of 00 here. So, can you assure that the symbol of the 00 was transmitted? Or do you think that the symbol of 10 was transmitted? Actually, this is so ambiguous. Actually, yeah, we don't know that. But when we use the hard decision, the demodulator just converts it into 00 because it's slightly closer to the symbol of 00, yeah, than the symbol of 10. However, the soft bit consider the probability. For instance, what is the probability that the first bit is 0 or 1? And what is the probability that the second bit is 1 or 0? In the case of these received symbols, maybe the probability that the second bit is 0 is very high because both symbols include the binary 0 for the second bits, right? But how about the first bit? Actually, this is the main problem. So, the demodulator withholds the final decisions and just pass it, only that the probability to the channel decoder, so that the channel decoder makes the improved final decision. But how can we calculate the probability? First, we can consider this condition probability of the bi given y here. It means that when we receive the symbols y, what is the probability of the bi? So, this is the conditional probability can be solved like the probability of y given by multiply the probability of the y. Actually, this is the base rule. And since we have only two options, binary 1 and 0, right? So we can express that the soft bit like log the probability of the y given bi is 0 over the probability of the y given bi is 0, right? So if the soft bit value is greater than 0 here, it will be binary 1. Actually, this is the log likelihood ratio. And the greater value means that more reliability. Yeah, actually, yeah, it means that more reliable. But, okay, yeah, let's discuss more about it later. So, okay, so far we learned about the concept of the soft bit, right? So now let's see how can we use the soft bit for the network coding. First, there is some conditions, yeah, to use the soft bit for the network coding. The binary 0 must be mapped into +1, and binary 1 must be mapped into the -1. Then the extra operation between two bits is equivalent to the multiplication between the modulated signals. For instance, the binary 0 here, XOR 1 is 1, right? So the binary 0 become 1 after the modulation, right? And the binary 1 becomes -1, right? Then when we multiply these values, it will become -1, right? And the symbol -1 become the binary 1 after the demodulation. So actually this is the same, right? 1 and 1. Therefore, using these conditions, we can know that the probability that B1 here, the probability B1 XOR B2 is +1, like this. This is when both are +1 or both are -1 to get the positive value. On the other hand, the probability that B1 XOR B2 is -1 is like this: +1, -1, and -1 and +1. Actually, this is to get the negative value. Here, the probability that the the probability B is the +1 and B is -1 can be expressed as these values. But now I will skip the details. How can we derive these two values here, this one? Yeah, I will skip it. But if you need it, you can find the details in this paper. I think you can find and you can calculate the operations easily. So anyway, in conclusion, this equation is for the soft bit based on the network coding. Here, B1 XOR B2 can be derived like this. So let's just see the example using the 12 relay channel. But here, assuming that there is a direct path between source node 1 and source node 3, and the channel condition of the direct path is worse than the path for relay. In the first time slot, node 1 transmits 0 here and here, and node 3 transmits binary 1 and here at the same time. And then each destination node extract the soft bit using the error operations. Yeah, since the node 3 transmit the binary 1, this error value can be assumed +1.2, and since the node 1 transmit the binary 0, and the error value can be assumed -1.2. Then in the second time slot, the node 2 to broadcast the XOR bit 1, yeah, to each destination node. And its error value can be assumed first point to here and here because the channel condition of the relay pass is better than the direct pass. And then, yeah, the receivers does the network decoding process using these sort of bits. Yeah, for instance, yeah, when we see the node 3 case, these error values can be put into this equation, and we can get the minus 1.2, right? Then we can make the decision if this is greater than or equal to 0, it becomes binary 1, otherwise it becomes binary 0. And so since the minus 1.2 is less than 0, right, it becomes binary 0. Actually, this is the desired bit of the node 3. It means that this bit was transmitted by node 1, right? Okay, maybe you can think that why we have to use the soft bit based network coding is so complicated. I don't need it. But most of the channel coding using the modern communication system use these channel coding schemes: convolutional codes, turbo codes, LDPC code, Polar code, yeah, and so on. Maybe you can heard about one of them, I think. Yeah, and these channel codes consider only soft bit instead of the hard bit. So therefore, if we consider the joint network and channel coding in the physical layer, we can achieve the improved performance. So finally, let me show you one example. Actually, this is just an example for your understanding. Yeah, there is no like this channel decoder, but most joint network and channel coding do the process like this. And first, here, the scale plus operation is the soft bit based network coding operation like XOR. When we received the weak signal from the direct pass, the strong network coded signal can be enhanced the weak signals. Even if weak signal here pass through the decoder, yeah, it may be still weak. This node can generate L2 even if this is still weak, but it can be enhanced by the strong related signal. Yeah, actually this is just a superposed operation. And then this node extract the strong desired signal L3 using on soft bit L1 here. Actually this is error free. Good. Okay, yeah, actually this is the end of the soft bit based network coding and the end of the lecture of the analog interval network coding. So yeah, let's summarize what we have learned so far. First, we saw the motivations and potential of the analog network coding. Especially the physical layer network coding can reduce the time slot to complete the communications. So its throughput performance is 50% improved than straightforward network coding method, right? Then we saw the analog network coding, that is the modified version of the physical layer network coding. It does not use any decoding stuff in the relay node, so it just does like amplify and forward relay method. Therefore, it can reduce the complexity than the physical layer network coding using the mapping algorithm, mapping rule in the relay node. But its performance is lower than the physical layer network coding because of the AF relaying method. Finally, yeah, we saw the soft bit based network coding. Since modern channel coding use the soft bit instead of the hard bits, so if we consider joint network and channel coding using the soft bit, the performance can be improved more. So, okay, that's it. I really hope this lecture was helpful for you. Okay, thank you. Thank you for attention. Thank you. Bye.